Just a few words on the BCM Fooler for the LTO 48 cell pack. So you'll be familiar with this. This is a standard BCM Fooler, and this one is made with 10k 0.1% tolerance resistors for added accuracy, and that's the MCM HV connector, and that is the BCM tap connector. So that's connected as normal. But on the this, you'll see there's some extra wires coming out of this little box, and that's because on the other side of this we have the plus 48 volt system. So what we have here, we have a few components here. I'll just go through these. So we have the DC to DC converter. This steps up our 12 volt supply to 48/50 volts, which is added to our LTO battery voltage. We have a load resistor here, which just keeps a load on this to hopefully keep it more stable. We have a diode here, which is in the 12 volt supply line to the converter. That's just dropped the voltage down by half a volt, because this is only rated to 13.2 volts, this particular one. Then we have a 12 volt relay here, and this relay is to it serves one purpose mainly, and that is to disconnect the HV system. So this interrupts the high voltage supply from the battery to the DC converter, etc. So this is ignition switched. So basically this means there isn't a parasitic load on the LTO cells when the car is off. So the converter is also powered by this ignition switched supply, which comes in here. That's just 12 volts from the ignition switch hold relay 12 volt supply, and that basically activates the relay, which completes the HV circuit, and it also powers up the converter, which adds our 50 volts to our supply. And then here we've just got the battery power coming in. This is the battery coming in here, the 120 volts or whatever it is, our LTO cell block, and it comes in here. The positive goes into the negative of this converter, and then the positive comes out and goes to the top of the BCM Fooler on the other side of this, as you can see. So that's what we've got. So that, I'm just going to put this in this little box and shove it on the top here somewhere, and then just wire this up to the battery, and then I've just got to connect this to the 12 volt MCM lines. Now we may want to change this for a 5 volt DC converter, because the 5 volt inside the MCM is much more stable than the 12 volt system voltage. So we might find the voltage changes too much with this converter. We might want to use a regulated 5 volt DC supply to supply it rather than the 12 volts, but we'll see how it works in practice. It may be fine, but if the voltage varies too much, then it might throw an error, but we'll see how it goes in practice. That's the least of the problems really, and we'll see how it all goes. So I'm just going to hopefully wire that up tomorrow.